Okay, pre-calculus. Today we are on Unit 2. That's not right. This is Unit 7, right? Day 8. And last class we were finding all the real zeros of a polynomial, and today we're going to find all the zeros, including the complex, the imaginary ones. So we're going to go ahead and first start with the complex and irrational conjugate theorem. So basically, if you've got a 0 at a plus bi, you also have one at a minus bi. And same if you've got one at a plus root b, square root of b, then you have one at a minus square root of b. And this is basically just review from Algebra 2, but let's just go ahead and fill this out. This can get a little tricky. So it says, write the equation of a fifth degree polynomial that has the following roots. So that means it's going to have we should have five roots, okay? So roots, solutions, x-intercepts, all means the same thing back from Algebra 1. So if we've got a root at 1, that's it, okay? But if we've got a root at 5i, we also have one at negative 5i. And if we've got a root at 1 plus I, we also have a root at 1 minus I. Now we have to be really careful about how we write these. So the roots written as factors, notice if I go ahead and put in 1 for x, that's going to become 0, so that is a factor. So it's going to be x minus the root, right? So this is x minus 5i and x plus 5i. And the reason it's plus is because it's still x minus, but it's x minus negative 5i, so it makes it a plus. Okay, now this one is where it gets tricky. So we're still subtracting these roots. So x minus the first root is 1 plus I, and then x minus the second root is 1 minus I. So what happens is this is really x minus 1 minus I, and that's because we have to distribute this negative to everything inside that parentheses, including the I. And here, same thing, x minus 1 plus I. Now we have to go ahead and multiply these out. So we're going to multiply these, these two roots, and then we're going to multiply factors and these two factors together because they're conjugates. So now we need to remember the property I squared equals negative 1. That is just something you have to memorize. It's a property. It's just a definition. So just anytime you see an I squared, you're going to replace it with a negative 1. Besides that, everything is pretty simple here. When you FOIL x times x, you get x squared. The outer and the inner terms are the same except for they have opposite signs. So those are going to cancel. And that's what happens when you have two factors that look exactly the same, but one has a minus in the center and one has a plus. Okay, so x squared, and then it's going to be minus, this is the difference of two squares, 25i squared. Now, anytime you see an I squared, you're going to replace it with a negative 1. What's going to happen there is that's just going to become a plus 25. So that's how you're going to write that. And you don't have to go through writing all that out. When you can go straight from here to here. Okay? Now let's move on. So now let's multiply these two factors together. So we got x times x. This is a little bit longer because it's a trinomial times a trinomial. And all you have to do is multiply every term in this trinomial by every term in this trinomial. So how to do that? X times x, x squared. X times negative 1, negative x. X times I x. Another color. Negative 1 times x. All right, so negative x. Negative x times negative 1 plus 1. And then negative 1 times I is negative I. Last color. Now I should use a different color. Purple. Negative I has to be multiplied by everything as well. So negative I times x is negative ix. Negative I times negative 1, positive I. Now negative I times I is negative I squared. We know I squared is negative 1, so that's going to be a plus 1 because it's negative I squared. I squared is negative 1, so it's a positive 1. Now let's see if there's anything that we can cancel. Do we have anything that's the same here? We've got an ix and we've got a minus ix. Those are going to cancel. We've got a minus I and we've got a plus I. Those are going to cancel. Anything else? I think that's it. We're going to add those two ones together. We're going to add the minus x and the minus x. So here's your answer. We've got an x minus 1. We've got an x squared plus 25. And we've got an x squared minus 2x, because there's a minus x and a minus x for a total of minus 2x. And then a plus 1 and a plus 1 for a total plus 2. That's it. It's asking us to write an equation of a 5th degree polynomial function that has those following roots. And there it is. Now, you can throw an a in front. The a in front just means, you know, this equation could be multiplied by some number a. But, you know, I'm not going to take off whether you have that or you don't. All right, moving on to the u-try. So try the u-try, and then I'll show you the answer. All right, so here we go. So if you have one at a root at 2i, you also have one at minus 2i. And if you have one at 3 minus root 2, you also have one at 3 plus root 2. Be careful about how you have to subtract the roots. So you have to do, when you write it in terms of factors, the first one you have to write x minus 3 minus root 2. And you also have to write x minus 3 plus root 2. And then you have to distribute the minus, which is where these come from. Then you have to multiply everything out, cancel everything, and see if you get the right answers. And if you want, you can throw an a in front, because there could be, you know, a number that you're multiplying the entire. It just says write the equation of a 4th degree polynomial. So if it's going to be general, might as well put a number in front, because we might multiply through the entire equation by some number. It's the general form of the equation. Okay, so to find all the zeros of a polynomial, it kind of starts off the same way as last class, where you write out the p over q list for the polynomial just to see what are all the possible zeros. And then you can, and this is a choice, you can determine the number of positive, real, and negative solutions, and that's optional, but it is useful. And then you're going to find the real solutions using synthetic division, and then factor the polynomial if it's possible. And then at that point, you'll have to solve, and you might be finished, you might not be, you might, let's just get there and see what happens. Okay, so find all the zeros of the polynomial. So we're going to put all the factors of p over the factors of, why did I circle that whole term? Q. Okay, so let's do that. What happens when we do that? Well, what are the factors of negative 18? It's always plus or minus. What numbers go into 18? 1, 2, 3, 6, and 18. Now, we're going to take all those numbers and we're going to put them over, what are the factors of 3? 3 and 1. If I put all these numbers over 1, I'm just going to get these same numbers, so we're done. Now, I got to take all these numbers and put them over 3 and see if I create anything new. If I put 18 over 3, I get 6, which I already have. So that is already on my list. If I put, what am I doing here? Okay. So we basically just have to look and say, all right, if I take all these and put them over 3, 1 over 3. Well, that's new. So I got to add that to the list. 2 over 3. That's new. 3 over 3 is 1. That's on my list. 6 over 3 is on my list. 18 over 3 is on my list. So these are all the possible zeros. And this was so useful back in the day when we didn't have a graphing calculator. When I was in college, graphing calculators came out at the end of my, when I was in grad school? Yeah, my senior year, I think I had access to a graphing calculator. So, I mean, yeah, this is like so useful. It's good to know how to do it by hand, but all right, so now what we're going to do is we are going to pick one of these zeros, and I usually try 1 or negative 1 first. And we're going to use synthetic division. We're going to throw it in and see if it works. Okay, so we're going to basically take this polynomial and we're going to divide by x minus 1. And the way we do that using synthetic, real quick way, is we start with 1. Okay, so here's our 0. So let's try it. So if it goes in evenly, if we end up having a zero as a remainder, then that means that it's going to be a root of this polynomial. So we go ahead and we plug in 1. And we do 1 times 3. And it is 3. Okay, 5 plus 3 is 8. 1 times 8 is 8. 25 plus 8 is 33. 1 times 33 is 33. We add, we get 78. Okay, we're not going to get, 1 is not going to go in evenly. Okay, what this means is that if I plug in 1 into this equation, if I just plugged in f of 1, I would get 60. Now, what that means is on the graph, when I plug in 1 for x, I get 60 for y. So at that point, the graph is in the first quadrant, okay? So sometimes that's useful information. All right, so now I'm just going to try, I like to try -1 next, okay? So I tried -1, didn't go in, okay? But I do know now f of -1 is -40. It's down here. So at some point between 1 and -1, the graph has got a 0. It's crossed somewhere. Okay? So then I'm going to look at my zeros and go, all right, I'm going to pick a 0 between 1 and -1 because there's got to be 1 there. So then I chose 1/3. And it went in evenly. That's always nice when you get your first one. Don't erase any of this work, by the way. Like, if it doesn't work, just cross it off and move on. All right, so you have to know how to do synthetic division to do this. And I believe I have a review of synthetic division. Yes, I did make one, synthetic versus long division, and I put it in, on my YouTube channel. So that gives me a remainder of 0. So I know it goes in evenly. So 1/3, I circled it. Okay, so there we go. There's one of our zeros. Now, at this point, that 3, we've divided an x out of this equation. And what happens is, when you start with 3x to the 4th, if you divide an x out, that's 3x squared. So this 3 represents 3x squared, x cubes, right? So at this point, I can, if I want, I can just continue doing synthetic division. You never start back, let me repeat this. You never start back doing synthetic division from the original equation, because then you will never end up with where you need to go. I'll show you in just a second. So I decided at this point I noticed that I could just divide a 3 out. So I went ahead and I divided a 3 out. 3 divided by 3 is 1, 6 divided by 3, and so on, so on. If you don't do that, I can show you what happens. You get the same exact thing. And then I said, all right, you know what? I'm going to try -2. Now, here's where the positive and negative zeros come in. So how many positive zeros are there? Well, let's look at the sign changes. Okay, usually you can do this first, or you can do it if you need it. I usually do it when I need it. So no sign change, no sign change, no sign change. Oh, 1 sign change. That means there's 1 positive 0. Now that I've found my 1 positive 0 at 1/3, I'm not going to try any more positives because I know that there's only 1. And that means with my negatives, since it's to the 4th power, right, I've got 3 left. They're either negative or they're imaginary. So when you plug in -x to see how many possible negatives you have, you end up having 3, and that means 3 minus 2, or you could have 1. So you could have 3 negatives, or you could have 1 negative, and that would mean you have 2 imaginary. All right, let's see what happens. So now the next thing I'm going to do is I've already tried -1. So on my list, I'm going to go to my next negative number. And I try -2, and it works. It goes in evenly. So now this means x squared plus 9, that equals 0. When I solve, I get x equals plus or minus 3i, because this is here. Here. X squared, why is this not working? X squared plus 9 equals 0. So x squared equals -9. Boom, it's going to be imaginary. We already know it. That's, if you take the square root of both sides, you'll get x equals plus or minus 3i. So there are 2 imaginaries. So if I had to go ahead and write out or list out my solutions, we've got them.